In its 600 years, the Forbidden City has withstood over 200 devastating quakes, including the deadliest earthquake of the 20th century. So how has the Forbidden City survived so many quakes? To find the answer, specialist carpenters are building a unique scale model to replicate the classic Forbidden City structure. To be as accurate as possible, it is being made using traditional carpentry tools and techniques. The scale is 1 to 5, a fifth of the original size. Engineers have built it on a shake table to simulate earthquake forces, calibrated to the size and weight of the scale model. These beams and columns are the structural core of all the Forbidden City's buildings.
If you look up here, in between the cross beams and the roof, underneath that mesh, there's these flower-shaped brackets, and they're called dogong.
The complicated dogong brackets extend to the exterior to support the eaves, as well as the roof. They sit on the large beams supported by the tall columns. But the columns are not founded in the earth and are freestanding. All these structural parts bear the roof's immense weight. Now, in a series of unique tests, the Forbidden City seismologist Dr. Joe will subject the scale model to a series of simulated quakes to discover how the Forbidden City's intricate parts react and see what magnitude of quake they can survive.
So a 9.0, this is like a very, very big earthquake.
The test now moves beyond magnitude 9.5, the largest recorded quake in history. The equivalent energy to well over 2 billion tons of TNT.
10.1级地震开始。攻克任务结束。
We wanted to break this building and it wouldn't break, so wonderful test.
When Dr. Joe and Richard examine the model, they find clues to how it survived the quakes.
这个红线呢，是这个地震前柱子的位置。我们可以发现呢，发生地震后呢，柱子啊移到了这里。
This explains why the columns are not founded deep into the stone bases. If they were, they could only break if overwhelmed by the energy of the quake. By being left free to move, they ride out the earthquake.
所以呢，这个柱子呢，它并没有产生破坏。
The design secret can be summarized in one word: flexibility. The wooden parts work both as individual units and together.
The dogong acts like a shock absorber in a car, and there's both friction and rotation that absorbs the energy from the earthquake.
The test also explains the effect of the heavy roof. It acts as a counterweight, pushing down so the flexible parts can ride the quake.
What was most surprising to me was how much the building could move, how flexible it was. Nothing was damaged, and it could survive a 10.1 earthquake. This is a fabulous proof of the genius of Chinese traditional architecture.